Okay, picture this. Imagine the people steering the global economy are using a kind of crystal ball to make their decisions. Now, what if that crystal ball has a crack in it? Today, we're diving into a paper by Stephen D. Morris that basically uncovers a ghost in the machine of the massive economic models that shape our entire world.
I mean, really think about it. What if the incredibly complex computer simulations that central banks use to predict the future of the economy have a fundamental bug, a hidden flaw that makes them act in really, really strange ways?
And look, this is not just some academic exercise. These powerful tools, they're called DSGE models, are right at the heart of policymaking. We're talking about huge institutions like the US Federal Reserve. And the answers these models spit out, they directly influence your life. Things like interest rates, job growth, and the inflation that changes the price of everything you buy. Which brings us to this very strange glitch that researchers kept noticing. It's a bizarre phenomenon they started calling the pileup problem.
So, what in the world is a pileup? Well, it's when a model, instead of giving you a sensible range of answers, just gets stuck. Its estimates for these crucial economic variables start bunching up in these weird and honestly often nonsensical patterns. The paper breaks them down into three main types. First, you've got what are called boundary estimates. This is where the model pushes an assumption to its absolute, most illogical limit. For example, it might estimate that people's patience, their discount factor, is greater than 1. You know what that means? It means people value the future more than the present, which is, well, theoretically impossible. But the model just keeps landing on that answer over and over. Second, you get these skewed results. So instead of a nice, balanced bell curve of possibilities, the model's answers are all lopsided. It's kind of like if you were measuring people's heights and found that almost everyone was under 5 feet tall, but then you had a few people who were 7, 8, even 9 feet tall. The data just looks wrong. It creates this long, improbable tail of estimates. And then there's the strangest one of all, multiple nodes. This is when the model gets so confused that it gives you 2 or more completely contradictory answers at the same time. It's like asking your phone for the weather and it tells you it's both 30 degrees below zero and 100 degrees outside. It just doesn't make sense. So what on earth is causing these incredibly sophisticated models to act so bizarrely? Well, it turns out the problem isn't always that the models are broken. It's that they're seen double. This leads us to a classic problem in economics. This quote right here gets to the absolute heart of the mystery. In certain economic models, you can have 2 totally different underlying assumptions. Let's call them theta and 1 over theta. And they can produce the exact same data that we see in the real world. The model looks at all the information and it literally can't tell which of the 2 assumptions is the true one. This is called observational equivalence. Yeah, this slide here really helps visualize that doppelganger idea. You have 2 completely different sets of beliefs about how the economy works, right? Assumption A and assumption B. But when you feed them into the model, they spit out identical results. As far as the data is concerned, they are perfect twins. And the model? It's completely stumped. And in these huge, complex DSGE models that central banks use, this doppelganger effect creates what the paper calls a pileup region. It's like a landscape of confusion where the model can just get lost. And sometimes one of the doppelgangers is a totally impossible scenario, but the model doesn't know any better. Other times, both are actually plausible, which creates this genuine, almost unsolvable ambiguity. Okay, so if that's the problem, how do you fix it? How do you help the model tell the real thing from its evil twin? Well, this paper proposes a really clever new method. The author suggests a different way of doing things, called the minimum chi-squared estimator, or MCSE. The best way to think about it is like a detective. Instead of trying to solve the entire crime at once, a smart detective first figures out exactly what happened and then works backward to find the most likely suspect. Turns out it's not only more accurate, but it also saves a ton of computational detective work. And this breaks down the logic perfectly. Instead of trying to solve the whole messy puzzle in one shot, you break it down into steps. So step 1, you estimate a much simpler, direct summary of what the economy is actually doing. This is its Varma representation. Think of it as just a statistical snapshot of the economy's behavior. Step 2, you take that clear snapshot and work backwards to figure out which set of initial assumptions, which doppelganger, is the most likely one. And get this, for step 3, the method comes with these powerful, built-in statistical tests, so you can check your work and make sure you got it right. So here's the really crucial point. It's practical. Because this method is more stable, it's way less likely to get tripped up by those weird pileup zones. And this isn't just about making life easier for researchers. Avoiding these computational nightmares means you get answers faster and with a lot more confidence, which is, pretty critical when you're making time-sensitive policy decisions.
And this is huge. This tool helps economists answer a vital question. Is this bizarre result just a statistical quirk, a harmless pileup, or is it a giant red flag that my entire model of the economy is fundamentally wrong? This new method actually helps tell the difference.
So, this brings us all the way back to that cracked crystal ball. Why does fixing these really technical-sounding glitches actually matter in the real world? Because by spotting and navigating these doppelganger effects, we're not just patching a few little holes. We are literally reinforcing the very foundation of the tools that economists use to understand and guide our world. And that reliability, it translates directly into confidence. When policymakers have tools they can actually trust, they can make better, more informed decisions to steer the economy, your economy, through recessions, through inflation, and through whatever comes next.
At the end of the day, this research gives us something like an X-ray for our economic models, a way to see the hidden fractures. And it leaves us with a pretty fascinating question. Now that we can finally spot these ghosts in the machine, what other unseen flaws in our economic understanding are still out there, just waiting to be discovered? The search is on.